Okay, so we wanted to continue with logarithm functions. So what is logarithm functions? Actually, logarithm functions is defined from the exponential functions. So for x bigger than 0, b is bigger than 0, b it cannot be equal to 1. This means two parts, 0 less than b less than 1 or b bigger than 1. Okay, y equal to log bx is equivalent to by equal to x. So these two things are exactly the same. And y equal to log bx is the logarithm function. Okay, so similarly, we will have two forms, logarithm form and exponential form. Log bx, byx. Okay, so how could you remember this? So this means, okay, so you have the base is the same. Both the base is b. And what will you do? You could change x and y. Okay, so you could change that x and y. Then it will be the two different forms. See? So if you the base, if you exponential form, if you keep the base log b, and y used to be on the same side with the base b, now it will be on the other side. Okay, x used to be on different sides of base b, now it will be on the same side. That will be how you remember these formulas. Okay, so now let's practice. So logarithm form 3 equal to log 8m. And what is the base here? 8. So you will write 8. So you write equal, yeah. So you used to have m and 8 are on the same side. Now where does m go? Go to the other side. And where the 3 go? Go to the same side with the base 8. So that will be exponential form. Similarly, so what is the base here? 7, so it will become log 7. So c is the same side with the base 7, so now it goes to different sides. And 33 is on the different side, now you come to the same side. Okay? So this also tells you, okay, so this if this is a logarithm equation, and this is how you solve the solution, yeah? So you can isolate the m, and you can isolate the exponent. How could you do that? Rewrite it in the logarithm form. Okay, so this is also the way to solve this question. Okay, so where the inverse, where the logarithm function come from? Actually, why do we need this? So actually it is from how to solve the exponential function. How could we find the exponent? So the inverse function, from the definition of the inverse function, we know that fx equal to b to the x, and then y equal to b to the x. You exchange x equal to b, x equal to by. And what will be the y? Y will be the log bx, that is the definition, yeah? So f inverse of x is log bx. So what does this tell you? Logarithm functions and exponential functions are inverse functions. At the inverse function, there is one very important property. They are always what? Symmetric to y equal to what? X. So that's very important. Very important. Okay. So let's review. Y equal to b to the x. This is when b is bigger than 1 is what goes up, increasing. When b is less than 1, it will be goes down. Okay, so what do you think will be the inverse function? What will be the logarithm function? The picture. Okay, so excuse me. So because it's symmetric to the line y equal to x. Okay, so it's symmetric here. Then what do we have here? So means you exchange your x and y coordinate. Here is 0, 1. Here it will be 1, 0. Okay, so it's 1, 0. Okay, so it will look like this. Okay, so similar for the logarithm function. So what will it look like? Like this. Okay, And for this one, 1, 0 here. So what it will be like this, because it's symmetric to y equal to x, yeah? So here it will be like this. Okay. So what will be the domain here? Domain here means the x value, yeah? So the domain is what? From 0 to what? Infinity, because domain is the range of the exponential. What will be the range now? Negative infinity to infinity. That will be the domain of the exponential function. You with me? At x-intercept, it used to be x-intercept, it will be the y-intercept before, yeah? So what it will be? 1, 0. Y-intercept, it will be what? None. Vertical asymptote. Do we have a vertical asymptote? Yeah. So it will be x equal to 0. Do we have horizontal asymptote? No, none. Okay, so you just change your x and y for the exponential and the logarithm. That will be the same thing. So maybe we will review here very quickly. What is the domain here? It's negative infinity to what? Infinity. Range 0 to what? Infinity. X-intercept, now y-intercept 0, 1. Vertical asymptote, now horizontal asymptote, y equal to 0. Yeah, so now look at these things. Just replace x and y, because domain is x, range is y. So if domain is x, range is y. So it just, okay, you could change. Okay, log bb. Okay, so there are some logarithm, important logarithm functions properties. Log bb equal to c. So what will it be? This is what? Logarithm form. You keep the same b base, b to the c on the other side, and then this b to the other side, yeah? So then what do you have? B to the power c equal to b to the power 1. Same base, then c equal to 1. Okay, so, sorry. So what does this mean? Log bb is always equal to 1. What happens to log b1? So it's the same thing, b to the power c equal to 1. But b1 is b to the power of what? 0. Okay, so this is a very important one. 1 is anything, any number to the power 0 is always equal to what? 1. C is equal to 0 then. So this is a very important one. So log bbx, what will be this one equal to? X. So you can do it very quickly. bbx equal to what do you want? Maybe y here. So what do we have here? It's b to the y, which will be b to the x. What will be your y? It's x, yeah? So this is your x. And similarly, you can do this thing. So you have to be x, and this one it will be 1 over c. Be careful, if the exponent is on the bottom, it will be 1 over c. Okay, on the top, it will be the same thing. Okay, so similarly, what will be the general rule? So if you have a log bc, bm, what will it be? Power on the top, keep it on the top. Power on the bottom, move it what? To the bottom. And then you have log bb. What is log bb? 1. So it's what? M over c. Okay, so this is this one. And then we wanted to use these rules to solve this properties to solve the following examples. Log 4, 64. What do you want? We wanted the 64 to be the same base with the bottom with 4. 64, it happens to be what? 4 cube. So which formula should we use? Number 3, yeah. So because BB base are the same, so we only have what? 3. So log 12. What will be 1 over 12? Is 12 to the power of what? -1. So same base, -1. Log 2 square root of 2. Log 2 square root of 2 means what? 2 to the half. It's what? Or half. Yeah, 5 log 5, 7. What happens here? 5 base log 5. So b log bx. So what does this thing equal to? 7. Ln ex. This one is a little bit trickier. Ln is actually log ex. So what happens here? Base are the same. Yeah. So what does this thing equal to? X. And what is the domain? Domain is whatever the inside here is what x minus 5 has to be bigger than 0, then x bigger than what? 5. What will be the interval notation then? 5 to the infinity. Okay, so these are the basic rules of the logarithm functions. Okay, so remember, logarithm functions and exponential functions, they are inverse. So they are symmetric to y equal to x. You just exchange your x and y coordinate, you will get what? Logarithm functions. Okay.